Hi everyone. We're going to solve exponential equations. We're going to start with the easy ones and get harder, and we're going to do 9 of them in this video. So the first one we're going to do is pretty basic, so you can kind of tell basically what the procedure is. And when we're solving, what we're looking for is our x. Since my bases are already the same, I just want my left side of the equation to look like the right side of the equation. Now, so what I'm going to do is I'm just going to set these two exponents to equal each other. Subtract the x and add the 1. So I'm subtracting the x. Let's do that in green. I'm adding 1, doing it together. And I get x equals 3. Okay? So if you want to check this, you can plug in the x. And I'm not going to check all of these, but you plug in the x, which is 3, back into your original equation, and you get 3 to the 5th equals 3 to the 5th. That would be your check. Okay? So I'm going to let you check a lot of these. Now you have a case like this one. We have 2 to the 3x power equals 4 to the quantity of x plus 2 power. Now in this case our bases aren't the same. So you go down, we're going to keep the left side as 2 to the 3x, but I'm going to write this 4 as 2 squared. And when you write that, you have to multiply that square part to whatever's already in the exponent. Now that my bases are the same, you can go ahead and just solve for x here. I'm distributing here. And subtract the 2x, and you're going to get x equals 4. And again, to check, you would plug that back in, and you would get 2 to the 12th equals 2 to the 12th. All right, and now I'm going to let you check some of these others. Now they're going to get a little harder. We have 3 to the 2x minus 1 equals 1/9. So basically, this is number 3. I want the bases to be the same. So what I'm going to do is I'm going to change this to 3 to the negative 2. Because 3 to the negative 2 equals 1 over 3 squared, which equals 1 over 9. Or don't forget your inverse properties. So now I'm going to write 3 to the 2x minus 1 equals 3 to negative 2. Now, since my bases are the same, I'm just going to solve for x here. You get 2x minus 1 equals negative 2. Add the 1 to both sides. So we're just adding 1. So you get x equals 1/2. You plug it in, you're going to get 3 to the 2 times 1/2 minus 1. And that should, that would have told you right away that we didn't do it right, because when I divided, I should have put a negative here. So I'm going to put a negative here. And when you take care of that, you're going to get 3 to the negative 1 minus 1, which is 3 to the negative 2, which equals 1 over 9. Okay? The next one we have is 4 to the x plus 1 equals 8 to the 2x plus 3. Again, my bases aren't the same. And I can't make this a 4. My base, I have to change both of these to base 2. So it's going to be 2 squared, and this one's going to be 2 cubed. And then we have to multiply it by whatever's in our exponent. So this is going to be x plus 1. This is going to be 2x plus 3. So all I have to deal with now, since my bases are the same, is to solve for x. I'm going to go ahead and distribute 2x plus 2 equals 6x plus 9. In this case, I'm going to go ahead and subtract 2x from both sides. And I'm going to subtract 9 from both sides. So you get negative 7 equals 4x. So x equals negative 7 over 4. You can plug that in and check, and it should work. All right. I'm going to go a little faster now, but they still, we have 8 to the x minus 2 equals 1 over 16. In this case, I'm just going to go as low as I can on the bases. So I'm going to do base 2. So I have 2 cubed. And this right here is really 2 to the negative 4. So you just need to know your inverse exponents. Now that my bases are the same, all I have to do is solve here. Adding 2 to both sides, so you get negative 2. And when you divide, you're going to get x equals negative 2/3. Okay, and the next one we have is 25 to the 2x equals 125 to the x plus 2. My bases aren't the same. My lowest base is 5. So I'm going to do 5 squared times 2x equals 5 cubed times x plus 2. And then just solve for x here. You get 4x equals 3x plus 6. So x equals 6. Now we're going to get into some radicals. We have 4 to the square root of x equals 16 to the square root of 5. Again, the first step is change your base to 2. That's 2 squared. And then multiply it by whatever is there. This is 2 to the 4th. And you just multiply whatever's there. Now we're going to solve. We have 2 to the square root of x equals 4 to the square root of 5. You divide both sides by 2, we get square root of x equals 2 times the square root of 5. Now what I'm going to do is square both sides to solve for x. So you get x equals 4 times 5, and x equals 20. And if you plug that in, it will work. 2 more. X to the, now these two are kind of hard, the last two. X square root of 3 equals 36 to the square root of 3 over 4. Now the first thing I notice is I can write this as 36 to the square root of 3 over 2. Now this is also 36. I can write this as 36 to the 1/2 times square root of 3. So basically this is the same as square root of 36. Square root of 36 is 6. So I'm going to write square root of 3 equals 6 square root of 3. I want the left side to look like the right. My exponents already look the same. So basically x must be 6. We just want the sides to look the same. So a little confusing in this regard, in this area. Okay, the last one is the hardest, which is x square root of 2 equals 81 over 1 over square root of 8. So the first thing we want to know is the square root of 8. Because I see this, square root of 8 is the same as square root of 4 times 2, which is 2 square root of 2. So I'm just going to write that. Which is 1 over 1 over 2 square root of 2. Now what I'm going to do is go ahead and, you can do this in several ways. I'm going to go ahead and pull out the 1/2. So I'm going to write this as x square root of 2 equals 81 to the 1/2 times 1 over square root of 2. Again, square root of 81 to the 1/2, it's the same as square root of 81, which is 9. It just looks nicer, so I know this is just going to be 9. So we have x to the square root of 2 equals 9 to the 1 over square root of 2. Now to solve for x, I'm just going to power everything by 1 over square root of 2. This part here equals 1, because that's going to be square root of 2 over square root of 2. So you get x equals 9, and square root of 2 times the square root of 2 is just 2, so that's to the 1/2. So x equals 9 to the 1/2, which is the same as square root of 9. Therefore, x equals 3. And that's all. Thank you. Have a nice day. Bye-bye.